Hello. Today we're going to talk about a different method in solving for equations. In the past we've used systems of equations, but in actuality you can use the remainder theorem to solve these same things. The first thing we need to understand is exactly what's communicated when they give us a certain number of points. And one of the things we have to recognize is if I have 3 points, that it can't be a line. And if I draw a quadratic, it's very particular about how this quadratic is put together. And if I were going to draw a cubic, there are lots of different cubics. Okay, so when I have 3 points, uniquely defined is a quadratic, and that's something that we have to understand. Okay, the next thing is its relationship to the remainder theorem. And as a reminder, the remainder theorem basically states that a polynomial expression can be expressed based on its quotient, which is a function, the factor that was being divided into it, and a remainder. And so what we do is we sort of utilize these very uniquely. And so if I'm looking at this information, the p of 0 equaling 28 gives me really an equation right away. Okay? So let's just kind of think about this. That's essentially saying that p of 0 is 28. That was the given part. Now, how does it relate to our polynomial function? And since we're going to have multiple quotients, we're going to call them a of x, b of x, and c of x. And so what this means is that there is some function a of x where x minus 0 plus 28 occurs. And so what I get is a function x times this quotient function plus 28. And this is the way that I can actually represent my equation. Okay, so when I divided by just x, I got this quotient function times 28. So you've got to remember that this is not a times x, this is your quotient function. Okay, and then I can use this with the next piece of data. So that means p of 2 is 2 times a of 2 plus 28, and that a equals 0. And so now I can solve for this a of 2 function. And so 2 times a of 2 equals negative 28. Divide both sides by 2, so a of 2 equals 14, which is just another remainder. Oh, forgot my negative sign. But since this is a remainder, that technically means that I can rewrite that a function, so a of x can be rewritten as x minus some quantity, that's your factor, times b of x plus a remainder. So if I look at this with the result that I just got, I have a new function, x minus a times b of x minus 14. And I can substitute this back in to my a function. So I can write it as x. And in this case, a was 2. So x times in the a function in place of it. So it might help if you guys look back at this is what I'm going to put inside of here. X minus 2 times some b of x function minus 14 plus 28, and this is considered my polynomial function. And we use our last piece of information to figure out what that constant is. So p of x equals 8 minus 2 b of 8 minus 14 plus 28 is supposed to equal 12. So you have to do a little simplifying. 6 times b of 8 minus 14 plus 28 equals 12. So if I solve this kind of in reverse, I'll get 8 times the quantity 6 times b of 8 minus 14 equals negative 16. Divide both sides by 8. I'll get 6 b of 8 equals negative 2. If I then subtract or add the 14, I'll get 6 b of 8 equals 12. B of 8 is equal to 2, and this is a constant. Okay, so you might be wondering how that works. Well, it works somewhat like this. I know that I had a quadratic, and I divided it by a linear. And that equals a linear. And then if I divide the linear again by a linear, that's going to equal a constant. That constant is this value b at 8 equaling 2. And so what I know is my b of x at any point is equal to 2. Again, you have to go back, substitute this all into the equation right here. So I'm back referencing this. And so I look at it and I'll say, well, x times x minus 2, b of x is a constant at 2, minus 14 plus 28. And if I solve for the, or simplify, I shouldn't say solve, I should say simplify. So now I have 2x minus 4 minus 14 plus 28. Keep simplifying, x on the outside, 2x minus 18 plus 28. Ran out of room. 2x squared minus 18x plus 28. This is my polynomial function. So that is my answer. If you were to use systems of equations to solve, you would also get that same answer. Okay? Stop, reflect is a very, very difficult process, but once you get used to it, it's actually quicker than doing systems of equations, especially as we get more and more terms in our equation. Thank you for your time.